Hello Internet, in this video we are going to be working more with our Quadtree and our voxels, and what we're going to be doing is we're going to be taking the first step in actually generating our mesh. And interestingly, we're not actually going to be creating any meshes at all. We're just going to be using Unity's primitives to actually fill this in. And so the idea is we're going to lay the foundation and try to figure out how to actually get this working, and then we can build from there. So what we're going to do is pull together a few things. So right now we just have 3 points. We're actually going to drop that, and I'm going to plug in probably an image. I may have to make that quick. But the idea is we pull in a texture, and then that texture will just be more or less a cutoff. And so we can actually look up the points in that texture and determine if it's either there or not there. And then that way we can actually fill in our Quadtree. And then with that, for each of the ones that it's true, for each of these small little actual inserts here, I forget which one this is. There. So for this one's just our normal point. So what would happen is this square right here would just be filled with a quad. And that quad is going to have the exact same size as it normally would. So theoretically, this shouldn't be hard. And so what we can do with this is once we get these meshes generating, once we get these quads generating, then we can extrapolate that out and actually do a mesh generation on top of that. So we can take out the quads and actually generate the mesh. And then once we have that mesh being generated, then we can run it through a marching squares, which is a simplification. Not really simplification, but it smooths out your thing so you can actually get horizontal or diagonal lines. So that'll come probably in a bit because I'm still figuring that whole thing out. I also want to throw in like a Perlin noise generator so that we can actually do this map generation automatically. I could probably throw just random at this and we get something, but it wouldn't look good. Wouldn't look good at all, honestly. So we're going to skip over that, and we're just going to take a texture and generate it from that. So figure let's get started. I've done a few minor modifications to our Quadtree, mostly just comments and a few other things. I forget what else I pulled out. It was something, no, I didn't add anything. Ignore that, going crazy. That's fine. So this is sort of our Quadtree. This is what we built over the last 2 videos. What we need to do now is we need to actually plug something into this. So I'm going to take out these points because those were just for testing. So we don't really need those. Those are actually not in there. Those are in our Quadtree component. So let's take these out. They're not needed. And then there's a bunch of inserts there. We don't need that either. And nothing else. Okay, cool. So those are all gone. We don't need those anymore. What we're going to do is we're actually going to create a new, we're going to create 2 components. We're going to create one for generating our mesh, and we're going to create one for actually generating our Quadtree, actually filling in the information into it. So I'm going to create something I'm going to call a generator. And so generators are going to be what actually fill in these Quadtrees. So we have a voxel from image, or image to voxel generator. Yeah, that'll work. So this is going to take a texture. And then from that texture, we're actually going to be able to generate a octree. Or not an octree, we're not working with those, Quadtree. So we're going to have a texture 2D as one of our inputs. And this will just be our image. And then we are also going to need, let's do a Quadtree component. I would say we'd use our Quadtree, but I don't think we can do that, because I don't think there's any way we can connect the two. Yeah, because we're just generating it here. so it's not actually going to work. One cool thing that we can do is we can actually pull out this regeneration of our Quadtree and stick it up here in our start, and actually pull this all the way up here. So our Quadtree is now just a public value, not a public value, we'll keep it private, but it'll be a Quadtree up here. And then we can make this private, so nobody else can see our stuff. And so this way we're only regenerating our Quadtree once, and then that onDrawGizmos method is going to be hopefully a little bit faster. I imagine that won't be the case, but I don't think we can fix it much beyond that. So we have our Quadtree component. We're going to need to be able to get it. And we've got our start. And that will just call generate, I guess. So let's build that function. I'd use the hotkeys, but they're broken still. So I should fix those. That would be smart, but eh. All right. And then what we need to do is we need to figure out how deep our Quadtree goes. Because what we're going to actually have to do is we're going to have to kind of interpolate and figure out where in the image we are. This isn't going to be a super fancy algorithm to do it. We're going to kind of write this so that it works and then figure it out from there. So I'm going to create something I'm going to call the number of cells, and that's going to be equal to our Quadtrees. And then that's going to be equal to the depth, actually. It's going to be a power. And so the reason it's going to be a power is because, well, that's just the way it is, but so your Quadtree is constantly dividing things by 2. So if the first iteration is there's just 1 square across, and then you divide that again and you get 2, and then you divide that again and you get 4, and so forth, and it just keeps going up by powers of 2, because every element there is divided into 2, or 2 across. There's 4, but they're stacked, so it doesn't count. So what we can do is, theoretically, this function is going to tell us the number of rows across our octree has. And just to verify that it'll be correct, I should be able to draw this. No, I shouldn't, because I turned that off. Oops, that was a mistake. Getting a ton of issues because I broke everything. Dang it. So I'm going to stick a null check in here. So if Quadtree is not null, then it will draw it. Otherwise, there's no point. So we've got our Quadtree. We're going to need a way to actually get it. So the way I'm going to do that is I'm going to make a public Quadtree that's going to return the Quadtree, and it's only going to have a get, so you can't override this reference from outside. So then, from in here, we're going to actually be able to insert things into that Quadtree that we just provided ourselves access to using these cells. So that's theoretically what we're going to do. For now, we've got the number of cells, and it's going to be, since it's a square, it's actually going to have the same height and the same width. So we can actually give x equal to and so we just need to iterate over both the cells in both the x and the y coordinates. And then based on that, we need to actually derive where that actually is, because this is a position, but it's not. That's going to tell us what cell in our Quadtree, what leaf node in our Quadtree we're at. The problem is it's not going to answer the final question because we aren't inserting into cells, we are inserting at positions, which may not be the best idea. but we can convert either way. There's two issues we're going to have. Either you're going to hit somewhere in physics and you're going to say, I want to destroy these cells, and we're going to have to derive the x and the y from that, or we're going to have to get an x and a y and then calculate that into world position and then plug that into our Quadtree. We're doing it this way. May not be the best solution. I've already thought of a few hiccups we're probably going to run into in the future, but we're going to go with this until it breaks, and then we'll fix it, which mostly is just to see if it breaks or not. Kind of curious. So we have our x and our y. We need these now in world space. So to do that, we can actually take our Quadtree to get that. So we're actually inserting a vector 2, which is going to be the position, and that's going to be equal to our Quadtree transforms position. So the world position of our Quadtree, wherever it is in world space. And then what we need to do is we need to take and add on the x and the y. So the position.x is going to be equal to x minus the cells over 2. So half of the cells. And this is just because we're dividing at the center and moving in either direction. So if our x is greater than half of it, it's on the right side, and if it's less than that, it's on the left side. And so that division should always, there should be no remainder from that division, because it's a power of 2, so it should always come out to something, or it'll be 0 because there's only one cell in the entire thing. So this is always going to give us an integer. If it doesn't, something else is broken. So with that, we can also multiply that by, how do we want to do this? I think if we divide it by the number of cells total in order to get a float. So this needs to become a float now. And so what this is going to give us is it's going to give us a factor between negative 0.5 and 0.5. And then if we multiply that by our Quadtree's size, which is the actual size of our Quadtree, that should, I'm kind of making this up on the spot, but that should be able to get us the actual position within our Quadtree that we want. And so if we duplicate that for the y, theoretically this is going to be able to locate something in our Quadtree, I think. For now, what's the best way to do this? So this generator is only going to insert things into the Quadtree. There is not going to be any mesh generation happening in this function at all. This is just setting up the Quadtree. So anytime you want to actually generate terrain, you'd make a generator, and then when you need to actually render it, we'll make a separate rendering class for that. But for now, we've got the position.x, position.y. Now what? Let's actually insert it into the Quadtree. So we take our Quadtree and insert it. We want to insert at our position, and we want to insert a true value. So this should fill every cell, which we should be able to test fairly easily. So we start it, and I didn't attach the generator, so we're not going to get anything. But if I do it, and then the image can stay null because we're not actually referencing that right now. But if I just assign the Quadtree, should assign it there, and then throw a null reference. Quadtree to Quadtree. Ah, I know what's happening. So we have two functions that are firing at the same time, and both of them, I think, do they? Yes, sorry. wrong place. Both of them are using the start. So we can fix this in a number of ways. The easiest is probably to just pull it out and stick it up there. Alternatively, we can actually stick it in awake, which is going to happen before start. So the start method is called, there's like an update loop that Unity does. So it does an update and then a late update, and then it keeps looping through that for every game object. So the issue we're running into is 2 of those updates are happening out of sync of the way we want. And so start is called right before the first update ever run on a game object. So it'll be the first time that component is awake, but it'll only happen at the update. So if there is no update, or if the update is wherever, then that's what happens. Awake happens before. It happens, I believe, as soon as the object is created. And so that's going to happen sooner. So theoretically, if we do it this way, the awake will get called, and then our voxel generators generate will get called. What appeared to be happening was our generate was called, and then it null pointered and then generated our Quadtree, which obviously that doesn't work. So now, theoretically, the Quadtree should be generated first. Looks like we have an off by 1 error. But, yeah. So we're off by 1 here. But everything else seems to be working. I'm curious why we're off by 1 on the x-axis, but not on the y. And I suspect we're wrong in more than this. I'm guessing we're subdividing 1 too many times. And we can actually test that. So we would expect the width to be 4 here, and it's 8. So we know that our depth is too big. So when we're generating our Quadtree, we are doing too much stuff. So what's happening is we're actually subdividing 1 too many times, because we're taking our first subdivision and we're not really counting that. We're saying if I wanted depth of 8, for example, but we're starting at 0 instead of starting at 1. So if we start subdividing, because we already have our first subdivision, that 0th node, the first initial node, that's our first subdivision. So when we actually insert at the top, we actually need to insert depth minus 1. So that should actually reduce the number of things so that our calculations are correct and we actually get the proper subdivision happening. So that was the error there. So I should be able to actually do this, and the off by 1 should have gone away. And it did. Cool. So that black magic worked. Now, what were we going to do? We have that. Seems to be working. Keep opening all the wrong projects. I should close those first. That would be smart. So now that we have this, what we can do is we should be able to either plug in an image and actually use these X and Y to get that, or we can do something else. So I'm going to actually see if I have an image, because I don't actually know. Maybe sample terrain 1. Oh, yes, I did make something. Cool. So sample terrain 1 is totally wrong. It doesn't really fit what we're doing. It's just more or less a bunch of random noise, but it should work. It's too long, obviously. It's 100 pixels wide and 25 tall, so it's designed to be stretched. We're not going to bother with that, but it should still work, I think. So what we need to do is we're going to pass in the image. We've got the image, actually. Now we need to figure out how to actually look that up. And so the way you do that is you do an image and you get the pixel from it. We might actually want to do some filtering. Get to pixel. Does this work? Yeah. Let's do So bilinear filtering is going to actually smooth out the pixels. Yeah, I would explain that right now, but I'm totally forgetting. So there's two ways it smooths things out. There's MIP mapping, which means there's a series of images and they get progressively less detail, and so it shows you less and less detail the further and further away you get from the camera. I don't think that's what this is referring to. This is referring to something else that I'm totally blanking on. I'm sorry about that. So more on that later. But what this is going to do is it's going to smooth out the pixels. We kind of covered this previously, but more or less it's going to interpolate between the two pixel colors and then smooth out between them. So if you have black and white, it'll make shades of gray between that. So with that, if we take our x and divide it by a floating value of our cells, and y and divide it by the floating value of our cells again, this should get us the UV coordinates, and since we're using UVs, it'll be between 0 and 1, which is what this is going to give us. So this should give us a smooth interpretation of wherever that pixel was. And I believe it returns a color. So we'll get a pixel out of that. And then what we want to do is we want to insert only the true pixels that are above 0.5, we'll say. Or actually, let's stick in a threshold here. So threshold. Uh-oh. Is that spelled right? I don't think that's spelled right. I'm going to pretend like that's spelled right. I'm pretty sure that's wrong. I used to think I was all right at spelling. Now I know I'm terrible at it, so we're gonna leave that and hope it's good. So if our pixel, we'll use the R value, I guess. It's just a black and white image, so any of the channels should be fine. But if the R value is greater than our threshold, then we want to draw it like this. So this will only insert things that are greater than our threshold, and all the other ones it's going to ignore. So if I start, oops, that's not, is it going to work? I already assigned it. Yes. No. Cannot be accessed from scripts. Is texture readable in the texture import settings? We should do that. That's kind of required. So not all textures, oops. Go away. Okay. So, as I was saying, what are you doing? Please stop. There we go. Okay. That was fun. So, sample terrain. We need to make it so we can read and write from it. I think I tried to do this in some other... I think when we were doing our last dynamic mesh, I tried to do something like this. And I totally didn't need to. Now we do, because we're not custom making our texture. We're actually importing it from somewhere else. So we need to make sure we can actually read and write from that texture, which is what this gives us. So with that enabled, we should be able to rerun this, and we should get this. Now, the problem with this, I don't know if it's correct. It looks correct-ish. We don't have anything on top, and we don't have anything there, and we seem to be denser down here. But other than that, no idea. So part of the issue, we don't have very many pixels in this. Like, this is our resolution right now, which is crap. And because of that, there's no real good way to know. Like, maybe it fell on a black pixel, and therefore it's gone. That actually seems to be the case for like down here. So we don't really know. but we can still work with this. So we're going to. And then we can actually, we should be able to tweak it fine. So the next thing is going to be our quad mesh creator. So this is going to be a hack, to say the least. And we're not ever going to actually use this outside of this little demo here. And it's mostly just to actually get the framework for actually, here's what our mesh should look like. So we actually have a visual representation, and then we can match that pretty much exactly with our mesh. So this is more, what's the fast way? And this way we can actually kind of make sure things are looking the way we want. So I'm going to kind of cheat. So we're going to actually have a generate boolean, and I'm going to set that to false. And so if it's true, if generate, then we want to generate a mesh, and then we want to set generate to false. So pretty much how this is going to work is in the Unity Explorer or Unity Inspector, you just check the boolean, it will generate it the next frame, and then it will stop. So it will only generate the mesh once, and then it will immediately stop after that. So theoretically, that's, I mean, it's not a good idea, but it's not a bad idea either because it works. So the next thing, Quadtree component, we're going to need that again. And so our Quadtree component is going to provide us a Quadtree. So when we're generating this mesh, what we need to do is we need to recursively iterate over every node, which I don't think is supported right now. So what's the best way to do this? I think we may actually want to do some sort of like graph structure, because eventually our nodes are going to need to know what's next to them, and that way we can actually do the marching squares. We don't necessarily need that now, but we will in the future. So I'm wondering if it might make sense to kind of do that now, but at the same time it doesn't really make sense. So no, we're gonna skip that for now because we'll get there when we get there. It's a little bit premature to start doing that because I don't know if it's a good idea what I'm thinking. Actually, I'm pretty sure it's a terrible idea, but you know, you gotta start somewhere. So our generate mesh is going to recursively iterate over every node. And then if it finds a leaf node, it's going to actually generate the mesh for that. And the way we're going to do that is we're going to do a GameObject.CreatePrimitive of quad. So this will just, we'll just call it a GameObject. Sure. So we're going to create a GameObject. We're going to do its transform, set its parent equal to the Quadtree dot transform. So that just, in Unity's hierarchy, that actually puts it underneath it, so it's actually parented to it. And so that way, everything is kind of associated, and we can kind of hide it all under our Quadtree. Again, just things to make it a little bit less awful. And then we just need to set the position equal to, well, actually we can set the local position equal to a vector 3, 0. And that should just put it right at the center of our Quadtree. And so this is totally pointless. There's no real reason to do this other than to prove that things are sort of working. So we have this. If I click generate, it doesn't do anything. Well then, So I've never used this create primitive before. Am I doing it right? I thought that's all you needed to do. One sec. So apparently you need to reference these three fun little things in your project or everything explodes. Apparently this is a thing that the mesh or the generate primitives have. So we need private references to each of these, and that will prevent it from getting stripped. That's coming straight from Unity's documentation. I didn't find like some hack or something. Well, it is a hack, but it's they told me to do it, okay? That's what we're doing. So we've got a private renderer and then a private filter, so these are just three private references. We're not using them. So they'll just stick around, I guess. And so theoretically that will prevent it from actually stripping out those abilities from our build, which apparently caused it to fail. Yeah. Okay, so that fixes it. That's weird. I don't like that, but it worked. So we're going to keep it. So all this is doing is it's creating a 1x1 quad in the center of our Quadtree, which is right now worthless, but we can do some cool stuff with this. So this is the wrong project. If we get over to our actual, or once we actually can iterate over our indices, our nodes, we'll actually be able to define things. So now what do we do? Good question. So we're setting the local position. That's all good. That's creating the transforms, assigning that. We actually don't want that local position to be that. That's wrong. It's actually going to be tied to the nodes, but we don't have those yet. So we need a way to iterate over our nodes. And I think we have it. So I can get the root here and then return the nodes that way. But I think we might want to write public IEnumerable. So we're gonna write a function that's gonna return a unsorted list of our Quadtree nodes of t-type, just our type that we're using, and we're gonna get leaf nodes. So the idea is this is going to return all of the leaf nodes from our tree, I think. So method has cyclomatic complexity of 1. That doesn't make sense. Return statement is missing. I get that. And so what we want to do is we want to do node, and we want to get the leaf nodes, which isn't possible. You can't do this. But we're going to make it so you can do this, because we're going to actually add another leaf node like this. Where is it? Is leaf? Sure. Get leaf nodes. It's going to return that. And so if this is a leaf, then I want it to return itself. Actually, I think this might work. If I remember how to do it, there we go. Yes. Okay. So, coroutines. We're going to use those. Well, I don't know if is it? Yes, it is. Okay. So we're going to use a coroutine. And so what that is think of it like a function that doesn't exit, I guess, is the best way to do it. So the easiest way to do this is think of if you have a for loop for int I equals, well, better way to explain this. Let's say you want to implement a function. Let's say you want a public I enumerable of integers, and you want to get a range. Now this function already exists, but we'll do this anyway. So what you can do is you could do a min, and I equals equal to the min, and while I is less than the max, or greater, less than the max, sorry, and then just increment I over time. So that's yelling at me for all sorts of things, but that's probably because that's wrong. But so what a coroutine lets you do, or what yield specifically lets you do, is it lets you yield return something. And so if I just return I here, this function it creates this thing. Min will be inclusive and max will be exclusive just because of the way I wrote the for loop. If you want to include both of them, you just do that. But what this does is it actually is going to iterate over this loop. And then every time it hits this yield, it's actually going to return an element in our enumerable. Think of it like an iterator. And so the cool thing with this is you can kind of write infinite sets. So if I want all the positive integers, I can just do I is equal to 0. And then, while true, yield return I. I++. So it increments after it returns it. So this will return, it'll actually return 0, 1, 2. If we want to do it this way, it returns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. It just keeps going. And so this way, you have yourself an infinite loop. But other things like link, for example, since it's lazy evaluated, if you only take 10 things, for example, so if I do something like, we're getting totally off topic, but this is cool because I think it's interesting. But if I do get range, these don't matter because we're not using them. Just think of it as getting the total positive integers. And then I want to say skip 100. So now we're at 100 and we have an infinite number of integers from 100. And then I want to take 50. What this gets me is this gets me the numbers 100 through 50. Actually, it might be 101 because we start at 1. Anyway, this is going to get us those positive integers from this infinite list. I say infinite, it only goes up to the max value of an integer and then overflows and wraps all the way down to the negative, but that's getting way off topic, which is fine. But what this allows us to do, I think, could be very wrong here, which would not be great. But what this allows us to do is it allows us to just return our current node, and otherwise we can just recursively call each of them. So instead we will yield, actually do we need to? I don't think we need to. We can just get leaf nodes on each of our subnodes. So for each node in our subnodes. Right? Yes? No? Maybe? Yes? Sure. And so I can just do node.getLeafNodes. And we can yield return that. And it's not going to like that because it's going to be separate. So we'd have to individually loop over those. So this, probably not optimal, but it should get us something close to what we need, I think. Kind of making this up on the spot. I am making this up on the spot. But anyway, so this is going to be actual for each leaf in our leaf nodes. We want to yield and return our leaf. So called on each called on our root node. This is going to bubble down. It's going to recursively call get leaf nodes all the way down to the bottom. If it gets to the bottom, it's going to return that, and then it's going to bubble all the way up. So either this will work, or it will infinite loop or something else weird and crash my entire computer, which probably isn't a great, great chance, but it could happen. So we're going to actually work with that. And so what we need is we need a for each leaf node in our Quadtree, and we want to get the leaf nodes from that. So there we go. That'll get us a ton of leaf nodes. For now, I'm just going to actually leave this here. So it'll generate a new quad for everyone and just put them all in the center, which for now I think is going to be fine. And then we'll see, not all code paths return a value. Oh, well that's why. Fixed. Cool. That should go away. Everything should be wonderful. There we go. Let's see if this works. No. But that's because I haven't hit this yet. And so we get a ton of quads. Cool. I think this is what we wanted. I don't know if this is what we wanted, but I'm willing to guess that maybe we might have considered something like this to be the answer. I don't know if that was any more help, but so what we need to do now is actually position these. So we need to actually figure out where do these go. And we can do that relatively simply because we already have the position, because our nodes have their position. So for that leaf, we just set the position like that. Done, I think. Yes? No? Maybe? We'll see. So plug that in. You get this again. Everything's going to be incorrectly sized, and it's incorrectly detecting these as leaf nodes, which I don't know if we'll fix right away. Probably not, actually, because this video is already super long. But the issue is the way we detect leaf nodes is not based on depth. It's based off of if they have any children, and these don't. Therefore, they're not leaf nodes. That's wrong. And we can actually fix that pretty easily. Let's do that after we get this working. Because actually that'll look really cool, because theoretically with all of that, I think, if I'm not mistaken, it should fill pretty much everything except, should fill pretty much everything. We'll see. Actually, yeah, it will fill everything, because we're not checking this if leaf is, did we not save the actual value? Really? Did I overlook that? Yes. Yes, I did. Nope, I definitely did. There's a value there. Never used. Good me. I did that well. All right. So let's add that. T-type of value. There we go. Can we get the value? No, we can't. So let's add that quick so it actually works. So all we need this for is so we can actually pull out true or false, which actually might solve our problem because it will incorrectly detect things as leaves, but the default boolean value is false, so we won't render it, which isn't really the best solution for that, but it solves it. So yay, I guess. So if that's the case, actually, we'll probably leave that for the next video. We do need to fix it. We just don't need to fix it right now. And so I'm actually going to leave that off and use a quick trick somehow wherever I lost it. There we go. I'm going to actually use a default of T-type here. So this is now optional, and if you don't provide it, like we're not going to do that for up here. We're just going to use the default empty value, which is going to be whatever it is. So for booleans, that's false. For objects, that's null. For like floating points and integers, that's 0. Defaults, and then the type is just going to return the default value for that type. And so we have that. And then we want to insert something. Insert a value. We're subdividing that value. We're not using the value, of course, because that would make way too much sense. And then so did we really just, yep, we really just subdivided it and then didn't do anything else. Figures. That may have been a mistake. So this is going to keep subdividing that. I'm starting to think. Yeah, that's going to be, okay, so this is going to be harder to solve because we aren't assigning the value. We're going to have to actually figure out when we get to the bottom and actually insert that. And we don't have that logic in yet, which is my mistake. But I think we'll do that in the next video, simply because, honestly, because it'll take more time than we have. I've already been recording for almost an hour now, and somehow I have to get this down to like 30 minutes-ish. It's not going to get down to 30 minutes. It's going to be longer. But anyway, we're going to move on, which means this won't work yet. So I'm going to actually take that out. And we'll get to that in the next video. But time constraints. Everybody has them. I just have to stay within them, I guess. So that's what we're going to do. Gives me something to do tomorrow or later tonight. We'll see. So we have this. It's positioning everything. The only thing it's doing wrong, well, the only thing I think it's doing wrong is incorrectly scaling it. So we can actually set that by setting the local scale equal to the vector3.1, which is just going to be a 1 vector in every direction. Not a 1 vector, it's going to be a unit vector, so not a unit vector. Sorry, it's going to have 1 on every angle. So x, y, and z are all 1, which means it's like unscaled. And then we can multiply that by our leaf size. And so if we use that, theoretically, it'll either be correct or too big. I think it should be exactly correct because our Quadtree is normally scaled to 1 by 1. And our Quadtree is normally 8, but it's 4 on either side. So with this, theoretically, it's going to be correct-ish because we're going to do the same thing. But we'll find out. Yes, cool. And it did exactly what I thought. Everything is filled. The only difference is now everything is kind of filled. Like you can see how it actually went through, but everything is filled with a quad that exactly matches the size of wherever it was in our Quadtree, which is what we were going for. This is what we wanted to end up with. So it's good that we're here. So I think we can actually probably stop here. And then the next step, obviously, is getting it so values get set, which kind of makes this a little bit less interesting, simply because we can't actually see the terrain that we wanted to generate. Our Quadtree looks like it was generated for it, but it doesn't actually have the values in there, which make it useless. So what we need is we need to actually get those values, and then we actually need to take that and do something with it. And so that will be the next 2 videos, probably coming out later this week. So next step, save values. After that, remove these quads and actually use a mesh generation to generate this. And then after that, either optimize that and do some sort of mesh reduction or some sort of marching squares. We'll need both of those to get this finally working, but either one of those can come next. And then after we get all of that working out, then we're going to have to handle some way to actually notify that changes have happened and actually update our mesh when that happens, which is going to be a whole other bag of tricks. I think we can use .NET and C# have events built into them, and we might be able to use that event system. Or we might be able to use Unity's because they built their own, which is similar, but I think it's a little bit different. But either way, this is where we're at. It's kind of boring to look at, but it's a bunch of quads being laid out exactly over our quad tree, which wasn't what I was going for, but it's where we ended up. So if there's anything you guys want to suggest, let me know in the comments below. I'd love to see what you're thinking and where you think this should go. If there's anything you guys want me to improve on, like stop or forgetting to, save values into your quad tree, then go for it. Let me know about that, because otherwise I figure that stuff out now. So if there's anything else I missed, let me know about that too. But until next time, see you, Internet.